All right, welcome back, everybody. Gonna jump in today. Don't get to do attendance. Kind of it. I mean, it seems like everybody's doing everything. Everybody getting on the Hawks okay. Homework looking pretty good, pretty easy so far. Have any questions? I'm always an email away. I answer emails annoyingly fast. Okay. So I'll always answer them, pretty much anywhere. Today I'm gonna finish up 2-3. That gets us, kind of at the ending of kind of the math section. Or the non-math section. There was, like I said, I don't count chapter 2-1 as like mathy because, well, it's basically averages. Okay, it's kind of simple stuff, okay? Today I'm gonna get a little ahead, not completely because, has everybody had a chance to get their calculators yet? Pretty much everybody's got that, because you're gonna need chapter 3. So I'm gonna jump into chapter 3 today. Now, good news about chapter 3, you don't have to have your graphing calculator yet. It's a good idea, okay? Because if not, you're gonna get bogged down just by some a lot of repetition, some needless kind of like time spent on things. And so, like I said, get those ASAP. You're gonna have to have them eventually, because eventually the equations are gonna get too long, okay? And you're gonna come say, how do I do this equation? And I'm gonna be honest with you, I'm gonna go, we can do it that way, or let me show you on my calculator how to do it. And you're gonna be like, but I don't have a calculator. I'm like, well, you need to go get one, okay? I do believe that the tutoring center still has some. I do know if you're in high school, I think they give them to you there. I don't know. But I do know that our tutoring center says they still have some. They're TI-84s, okay, which are good. There will come a point, and I'm going to try to use the best of my knowledge and memory to remember this. I'm lucky that I have a wonderful staff and bookstore and everything, that they bought me a really nice calculator. I love it. It's backlit. It's fancy. And it does everything yours does. Now, mine does one step further on a couple of things. And you'll know, okay, whenever I start saying something, eventually you go, Professor, ours doesn't do that. Remind me if that happens, okay, and I'll go, oh yeah. And I'll just make sure to show you how your calculator is gonna work, okay? Some of you, now, if you get the TI-84 Plus, which I don't suggest that to anybody ever to buy, okay? It does what mine does, but TI-84 and just below. Well, remember, I'll try to help out. It's gonna be blatant. Okay, this isn't till like chapter 6 or 7, but you're gonna know really quick. You're like, how did he do that with a button? We don't have that button. Okay, there's still a button, but I have to kind of adjust for y'all. Okay, so today we're gonna finish up analyzing graphs. Super simple. If you've done 2-3 so far, it's really simple. Not a lot of stuff in it to really think about. It kind of goes along with everything we've talked about. Remember, you got your frequency distributions, okay? Kind of keep a tally, okay? Then you got the relative frequency, which is a percent. That's going to be your F over N. Remember, it has a little n. I'm going to be saying that a lot because little n always means sample size. You're going to need to know that, okay? I promise you. And then, like I said, that's some pretty easy math in that one. Really, the scheme of things with chapter 2 is this. And like I said, being transparent. If this was a statistics class I controlled wholeheartedly, and there wasn't like an online portion out there that I didn't want to teach, because I don't really like teaching online all that much. I'd probably get rid of chapter 2, because to be honest, computers do everything for you now, all that kind of stuff. You know, and they do them better and they do them faster. And that's what your boss, when you have him one day, he's gonna want it. He's not gonna want you to go buy some graphing paper, staples, and like get your colored pencils out and give yourself like a little bitty you know, bar graph. He's gonna be like, dude, you're a lawyer. What are you doing? Okay, or whatever. Okay, no, you can just pop in your data into Excel or MATLAB or stuff, or R. It's a programming language for statistics. It does it for you. It's done in 10 seconds. You're good. Here you go, boss. Get a raise. Buy that Porsche or whatever it is, popping it out. There you go. Okay. But until that time, we got this. Now, this chapter I would say is relevant. This one right here, 2.3, I would probably never get rid of this one. This is basically the one that says, hey, do you really know how to read a graph? You know, and people will say, yes, I know how to read a graph. I read them all the time or whatever. But do you really read them? Like, there was a poll that came out recently that showed that like 87% of Americans don't know how to read a poll. Okay? Or don't know how to read, like, graphs when they're shown on the screen. Okay? Because most people don't. They just look at them and go, well, that's whoever I believe in said it. And so there you go. That's the truth. When in actuality, it's not really the case. So analyzing graphs, we're going to go through it really quick. It's a super short lesson for 2.3. And starting off where we kind of left off in 2.2 was, hey, remember when I was teaching you how to build a graph, there's some certain things it needs, right? Well, remember, it needs a title. Title tells me, says, okay, this one right here, the generational divide over American exceptionalism, there you go. Okay, it gives you some data. It tells me this is what I'm looking at, okay? Then you need clear, very clear X and Y axis titles, okay? I also want you to kind of keep an eye on this. Always kind of look, everybody remember what the origin is in a coordinate plane, 0, 0? Always kind of look at that area. What's happening in that area at the 0, 0 mark? What kind of numbers are they using in that area? Okay, we'll get more of that in just a second. You should always include a source. This is if you're doing a graph for some professor, for me, for a science professor. If you go work somewhere and you give it to your boss, what's your source? Okay, is it you? Did you go collect it? We'll put you down. You deserve the credit. Okay, and then of course you can't have a graph without the data. You got to have data. Okay, otherwise you just hand your bosses a whole bunch of empty stuff. So there you go. Now some rules. And I say this in quotation marks because me and the one of the tutors, we were talking about this, that we like this chapter, but there's a couple of questions in Hawks that we hate. And we actually would argue, if Hawks was here, like if there's a person, we'd argue with him and go, I really don't agree with that. Okay. But most rules say this, that at the origin, your graph should always start at 0. Okay. So this one, notice it does. There's a 0% there. Okay. The reason we say that is because there was a graph that just came out about a year ago. I'll kind of draw here off on the side. It kind of looked like this. Just very quickly. And it showed this. Showed a line there. And then it showed a line like that. And I'm not going to tell you I'm going to make up what the graph said. It said basically, and we're going to go party A and party B. I'm not going to say Democrat or Republican. You're not going to get it out of me. Okay. But they're going to say, hey, party B, okay, they love killing rabbits. Party A loves killing rabbits less. That's kind of what we're going to pretend like that said. And you can kind of see that from the graph, can't you? Because this was like way up here. This one's way down here. Until you actually look at the numbers on the graph. Okay. This here was at 0.3. This here was at 0.35. That may not sound like a lot. Until you zoom out from the graph. And let's start it at 0, like it should. You started at 0, so here is 0, and then we'll put 1. This is what the graph looked like. Notice how they really, what they did is they zoomed in so they could really exaggerate that literally 5/100ths of a difference. But they showed it. So notice how you can kind of be deceived on a graph just by, if I zoom in and make things look a little bit weird if I wanted to, okay? So, a few more graphs you need to learn about. Now, I think on Hawks, if you've done the homework on this, I think it just says, hey, read this, do some data, okay? First graph here is what we call a time series graph, okay? This right here is an actual Bitcoin. You can see how it's kind of tracked. Yes, they will take graphs and combine them. This is a combination bar graph and line graph. But whereas in this time series is it's over a period of time. It's over 1 month. What happened to the price of Bitcoin over 1 month? Well, you can notice it started off at 1 and then took a big dive and then took a big, it raised, it went up. Okay, but I can see what it did over a period of time. Okay, so that would be a time series graph. The bar graphs underneath, those are just telling how much was sold or bought in a certain day. Well, here is a cross-sectional graph. Cross-sectional graphs say this: what happened at a specific point in time? Okay, like right now. And this one is saying what happened to these 15 and 24-year-olds. This is going off of what? A medium household income. Notice they give me a source. Okay, they give me very clear X and Y axes. Also notice it starts at 0. So we're not going to make things look a little weird, like by zoom in and try to make things, try to put a narrative to it. You can see that most people start gaining the most money between 35 and also 54. And then after that, it starts to drop. Reason it starts to drop, you can kind of infer people start to retire, which means they make less, but usually by that point in time, hopefully sometimes you have less bills. Maybe people's houses are paid off, or they're not buying the expensive houses. They've gone to a smaller house. Kids are gone. We don't need the 5-bedroom house. We're going to go to a 2-bedroom house, something like that. So bills become less, so you can make less money. And of course, you actually make the least amount of money they've found between 75 and above. But notice it's times. This group at this time, here you go. I didn't measure a 75-year-old group over a period of time. It was this specific time. When are they 75? When are they 54? Kind of makes sense. And here's a graph. I want you to think about it. U.S. federally allocated minimum wage rates unadjusted. Okay. Starts at 0. I got a title. I got a source. You're gonna have to talk. How do you feel about that graph? You like it? What is it telling you?
Minimum rate.
Right, but what is it saying? Like if you had to explain that graph to somebody, like you're gonna explain to your boss, you hand that graph to your boss and go, here, girl, here, boss. What's it saying?
Minimum hourly wage went up over time from 1938 to 2009.
Did it happen fast?
Steadily.
Really steadily? Like it was kind of a constant rise over time? Everybody agree with that? You don't have a problem with that at all? I just lied to you. That's the actual graph. None of you looked at the bottom. We call this scaling. Look here. If you look at the very bottom, notice my first date, the 24th of October, 1938. Okay? And then the next one, the 24th of October, 1939. Then the next one, the 24th of October, 1945. Why did I skip 6 years?
Hollywood.
And then all of a sudden I went to join the 25th of January, 1950. And then all of a sudden, March 1956. Do you realize there's no pattern there? No pattern at all. I'm just picking and choosing dates that I feel like look good. But now, yes, did it still rise? But was it as dramatic? No, now it's not as dramatic. Okay, so that's a real representation of what you'd actually see. So this right here, if I'm a lawmaker, I could be like, hey, we need to do something because look, people can't afford things because look how we're not keeping up with, whatever, however I want to make the narrative, right? Things are just going up consistently. Dude, since 1938, it's just been on a continuous rise. Couldn't I say that to you? And you'd believe me. Then hopefully somebody else would come in after me and go, well, if my candidate would actually show the right graph scaled correctly, you can see it hasn't been dramatic. It actually has been a slight rise. Oh, I don't know, between the 75s and 80s, it went up because maybe inflation and, gas prices. And then it's kind of risen, but man, it was stable for a long time. So notice the difference, the scaling. Make sure whenever you're making a graph, like I said, nowadays, if you're letting a computer, it's gonna scale it right. But does that mean I can't go in there myself and rescale it? Happens all the time, okay? Anybody on Reddit at all? There's a wonderful Reddit post, or whatever they call them, called Bad Data. That's all it is. It's people literally just like, they're just sitting around watching TV and all of a sudden like CNN or Fox or a teacher puts like a graph up and it's like, that's stupid. Why'd they use that? And so they'll take a picture of it and post it. And it's like daily. Some news organization somewhere shows a graph and they put on there and go, what's wrong with this? And they'll go, oh, well, it looks like this, but this is what they're saying. And they're like, that's not what that graph is saying at all, and it's quite hilarious, especially during these last elections. It was like daily, and it was both sides. Republicans will put something down. It was like, I can't believe they put that down. Then Democrats will put something down. Like, I can't believe they put that either. And they were just completely made up. I'd say when you actually kind of pulled the data, even some of the sources didn't match. Like one time they showed a graph, they talked about employment rates, and the source came from like the United Egg Industry or something like that. Why that meant? It's like, oh, well, if you're gonna get a job in eggs, you're about to lose your job. It's like, okay, so it was kind of funny how all that worked. There you go. Midterm questions. Okay. What type of graph would this be? We would call this a uniform graph. Basically, everything's kind of lined up. Okay. Very, very straight line. Notice it's not perfect. We got some that are a little bit high, a little bit low, but everything can kind of be considered in a straight line. Okay. Gonna need to remember that, especially for chapter 4. Symmetrical. More or less, remember, as I said on day 1, nothing's ever perfect in statistics. Okay. But this is roughly symmetrical. Symmetrical means I could cut it in half. And roughly things are about the same on either side, okay? Now, here's one that people miss a lot, okay? And it makes sense. This one is called skewed right, okay? It skews toward the outlier. So notice this one says test scores, number of students. Well, there's that one student who made 104.5. Okay, he's the outlier. He pulled everything, or she pulled everything in that direction, and so it skewed everything right. The high part is not the skew. Okay, it's the low part. That's what you're going to need to remember for the skew. Okay. Same thing for skewed left. Okay. Once again, there was somebody who pulled the graph in the other direction. Okay, so that's what causes the skew. Okay, so skewed left, skewed right, uniform, symmetrical. You can have things that are the same or sort of a combination of both, especially with uniform and symmetrical. You'll see that in the next homework problem I got view here for you. This one right here, notice it shows you a graph. This is some of your Hawks homework right here. For the set of data displayed below, describe the most likely shape of the distribution. Okay, symmetrical but not uniform, skewed to the right, uniform or skewed to the left. Which one do you think it is? What'd you say?
Symmetrical but not uniform.
Symmetrical but not uniform. That would be exactly right. Symmetrical because I can cut it down. How I remember this back when I took this class is, I used to read a lot of Batman comic books. So I always imagine Batman running across the roofs. Well, imagine on this one, if you tried to jump on that roof, you'd fall. Okay, but on a uniform one, you should be able to jump from roof to roof pretty easily. Okay, this one you can't. There's a big drop off, and so it's not going to be uniform. Okay, this one right here. This is the one with a source of contention for step 2. It says how many times as many robberies were there actual in year 4 compared to year 2? Round your answer to 2 decimal places. Now, this is going to require you to decide which graph that you can actually read data from. Okay. Notice you've got the robbery counts for graph A and then counts for graph B. Which one's easier to read though? Like if you were gonna have to look at the data and read it. Which one? Hey, exactly. You can kind of see that everything's going up in increments of 5, so you can see the midpoint, okay? So notice in year, what, 5 or 4, we have how many? Yeah, 255 right here. Well, how many in year 2?
225.
Very good. Well, the question is, how many times more robberies happened in year 4 compared to year 2? And all you do is simple math, you're gonna do some division. You're gonna do 255 divided by 225, and you're roughly going to get, when you do the math to that, 1.13. So that would be your answer for that one. There was 1.13 amount of 1.13 times amount of robberies in year 4 compared to year 2. You can check your math on that, do 225 times 1.13, and you're gonna get rough, it'll be like 249.99999, close enough, it'll round up to 255. Okay? Now, this is where me and the tutor both agree that Hawks is wrong. And yet, unfortunately, they're right at the same time. But it says here, which graph do you feel better represents the data? A or B? Got A, got B, what else? You're allowed to have an opinion. Both? Both. Hawks, the right answer, in case you want to know, because you're gonna get this question. Hawks is gonna pick B. Okay. Technically, Hawks is right. Technically, let me tell you why. Where does my graph start? At 0. Where did I tell you they need to start? 0. Do you really realize, if you kind of look at this, I'm gonna pick on them. Older people, me included, we tend to think more about crime than younger people. We think about it where we live. We tend to vote based on who's going to protect us the most sometimes, okay? So if I was running for office and I wanted to tell you, man, crime is on the rise. Look at that. Looks like it is, isn't it? But the actual, is it really on me? Yes. Is it on the rise? But is it as dramatic as what we think? Look at the slope. It's a very slight slope. Okay, so it's not that it goes up, but there's also more people every year. So that kind of makes sense that there'd be a little bit more rise, but it's not as dramatic as graph number A. Now, the reason I like graph A, guess what? I can read the numbers. That's where me and the tutor kind of agree, like, I can read it. Like, I can at least say, I get it, it looks like it's on dramatic rise, but I can say, dude, that's only 220, that's only 270. That's not a big difference when it's really, really honestly, when you kind of consider the whole big picture of the thing. Now, I could get it where people could like, look at the dramatic rise because, like I said at the beginning of class, most people don't read the graphs. They just look at the picture and be like, he's right. It's gone up. There it is. We're doomed. Instead of stopping and going, maybe I need to look at that graph a little closer. Are they really telling me what they're telling me? Or are they really pulling it from where they're pulling it? Make sense? And that's exactly how 2, 1, 2, 3, that's how we end. So hopefully with 2, 3, you really just kind of learn, okay, slow down, read graphs carefully as you move forward in life, okay? Because regardless of what you say or don't say, eventually graphs are going to start dictating what you do, okay? Eventually, some of you, if you haven't started yet, some of you are going to start to vote, okay? Once again, as I also said, it's a data-driven world. They're not going to start showing you a bunch of numbers. They're going to show you graphs, okay? Which job? Which college are you going to go to? Which one's the best? They're going to start showing you graphs. Are they valid? Oh, but those are the kind of things that are going to kind of rule your world. Good. Any questions over 2, 1, 2, 2, or 2, 3? Pretty straightforward on those. All right, I'm going to jump into 3, 1. Like I said, we're going to start this slow process of getting ahead. I'm not going to get to the whole lesson. So if there are some of you that do not have your calculator yet, you will have a chance because come next week, we will start using our calculators pretty much more and more and more, okay? When we get done with chapter 3, you'll have your first quiz online, your 1-3 quiz, but then you're also gonna have what we call an empirical quiz, okay? It's an in-class quiz, okay? It's listed, it's in your calendar, you can look it up, okay? So you'll know. Get back up here. This is also the end of my actual slides. I will be using more, just PDF right now, because I'm gonna do a lot of writing now. So that way y'all can see how things work. And it's a lot easier to write on a PDF than it is to write on a PowerPoint. So, measures of center. Now we get into math. Now you're in math class. Okay, so create the time to start paying attention. Like I said, most people don't fail this class. Okay, the ones that do, which last semester none did. Okay, the ones that do don't pay attention to the math. Okay, because the hard part is remembering what button to push on the calculator. Okay, I promise you. Okay, so measure the center. What's it gonna look like? Well, get extra calculators if you have them. Okay, if you don't have them, don't worry. Just make sure to bring them next week. Okay. So types of measures. You've heard these all before. Okay, these are not made up. You've heard them. Okay, you're gonna see them a little differently now. Okay, you're gonna realize the reason for them. Okay, the first one, and we'll probably get through mean today. I might get to median, but I really want to get to mean. We're gonna use mean a lot. And you're about to start learning some Greek today, so get ready. Okay, so get your notes out. Mean, here we go. Notice we have two different types of mean. I warned you, it was gonna look mathy. Now, don't be looking at this going, holy crap. No, 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 no. Remember, your calculator does this for you. Right now, I'm just showing you formulas. So, types of measures of center, mean, measures of center. When you start collecting data, you're gonna start seeing, and you don't really realize this until you start collecting lots of data, things start kind of piling up in the middle. Okay, a lot. Okay, they get larger and larger and larger, and that's just kind of the way things work. Okay. Now, look at these very carefully. Okay, they are almost identical equations. Now, remember here, I taught you this right here. Remember, anybody remember what that guy's called? Sigma, but what are we gonna call it? Summation. Okay, I'm gonna tell you why right now. Okay, here pretty soon, I'm about to give you another symbol that means sigma as well. So 2 that means sigma. Well, let's give one of them summation. Okay, so remember that guy right there is summation. Very important. Okay, what is that saying? Well, that's saying to do a sample. I take a sample. I take a sample of you guys, not all of you. I just take a sample. When I want to find the mean, remember when you found that? Average, mean and average mean the same thing. You just add them up, right? This to this to this to this to this, and then divide by the number of things you took a sample of. That's exactly what that's saying. I take a sample, and then remember this guy. I told you, what is little n always going to be in this class? Sample. It's always going to mean sample. You're going to need to remember that, because later on, that's the difference between doing this equation or this button and this button. Okay. So yes, this right here, or even here, these both mean sample size. Good so far. So now, dedicated, like you need to know this, remember it, tattooed on your neck, I don't care what you gotta do. Okay? This guy right here, okay? Sample mean. It's written next to it. But you need to remember it. It's called X bar. X bar will always be sample mean. Okay? I want you to remember that. We're going to deal with it a little bit right now. And then it's like he's going to disappear. And you're going to be like, oh, we'll never use him again. And then we get to chapter 6, you're like, oh crap, he's back. What is he again? We're dealing with samples. Remember, I've told you, chapters 1 through 5, I'm gonna start teaching you how to deal with populations. Okay? Kind of a misnomer. If I was doing a study of you guys, just you, not the JC, not all my statistics, not even the Zoom people, just you guys right here. Do I need statistics? Think about it, do I? Why? Why would I need it? What is statistics for really? To study what? A population, right? Well, aren't you a population if I study all of you? You're my population of this class. I don't need statistics at all. I know everything I need to know about you. Now, I need statistics later on whenever I say, okay, well, I'm gonna take a sample of you and then I can generalize this, okay? So right now, I'm gonna teach you how to work with everything. And then I'm gonna teach you, okay, you know the rules of this. Now let's learn the rules of this. So that's what I'm kind of teaching right now. Now notice, right now we're dealing with X bar, sample, but what's beneath it? Okay, your first Greek, except for signal. This is called mu, M-U. And I will say it. I'm not gonna say at population mean, I'm gonna say mu. Okay? Anytime you hear me say Greek, except for our summation notation. That's why I'm calling it summation, right? I don't want to use Greek for something that can be used. Look, I'm using that summation on both of them. When I say Greek, you should, in your head, that's population. It's always population. Greek is always population. I promise you this is going to help you out. Okay? So here, mu, okay? It's like a backwards U with a tail, okay? You'll see me write it a lot. And then, okay, can anybody take a guess on what that big N is? The population sample size. Very good. I heard her too. So you got it too. I heard you. Population. If a little n is sample, big N means population. It will always be that way. Okay, for example, yesterday I was teaching slope to my intermediate algebra students. Remember when you learned slope? M equals slope. And then I said, hey, M will always equal this. Same thing for you. Little n will always be sample size. Big N will always be population. I don't care where you're seeing it. I don't care what the formula is in this class forever. There you go. You see a big N? They're dealing with populations. Okay? So, population sample. Well, I'm not gonna say sample. When you do population, there's no sample. It's the population, it's everybody, it's everything in that. However, the many counts that you're using, it's all of this. Good, so far? Okay. Very simple. Now, I'm gonna show you the ugly math way to do this, and you would do it, but then guess what? I'm about to show you how to do it in your calculator, and you're gonna be like, dude, why didn't I have this thing like 2 years ago? Okay, and now you're seeing the reason why we didn't let you use it in college algebra and all these other things. First off, did you know the calculator you're using does the quadratic formula for you? Yeah, it's amazing. Yeah, you only just plug it in, it solves it for you. Okay, so notice to do a sample, don't do this. Let me just show you the math, and then I'm gonna tell you the calculator. Okay, remember the math says this. I'm going to take -7 plus 6 plus -6 plus 5 plus -5 plus -11, and I'm going to divide that by what? 1, 2, 3, 4, 5, 6. And I'm going to divide that by 6. When I do that, okay, I'm going to get a certain number. Okay, when I do all the math to this, I'm gonna end up getting -3. That's all fine and dandy, right? And if you want to do that, great, have at it. If you only got a scientific calculator right now, have, you can do it that way. Here's something pretty cool. Now, unfortunately, and they can't tell me why, the dot camera's still not working. Once I can find a way to get this working, I can really show you what I'm doing on my calculator. So right now, you're just gonna have to hear me how to get there, okay? If you take your calculator out right now, okay? I'll write it down. Here's your calculator. There's a button in the very upper left-hand corner, and it is called stat. Not stat, I'm sorry. Yeah, sorry, look for your stat button, and it's gonna be kind of in the upper left-hand corner. It says stat, okay? After that, you're gonna go to a button called edit. And then you're gonna see a list. Okay, everybody see that? Has everybody gotten there so far? Okay? So once you get there, you're gonna get to list. Guess what? List all those under list one. Okay, you're gonna see it looks like this, okay? Like there'll be an L1, an L2, an L3. They'll have lines like this. You can literally put every single number in there, okay? You hit a number, hit enter, hit a number, hit enter, hit a number, hit enter. Believe it or not, you're gonna use this function, this list function of your calculator a lot. So kind of remember how to get there, okay? We're gonna use, I'm gonna show you some really, really ugly math later. You're gonna be like, oh crap. And then I'm gonna go, or use the list, it does it this way, okay? Now, watch this. Let's come in here, back out of it. So you get out completely after you get everything in your list. You're gonna go back, you're gonna hit stat again. Okay, now, instead of going to edit, you're gonna scroll over and you're gonna hit calculate. The calc button, there's like a calc thing. Scroll down to where it says 1 bar stats. Okay. It'll give you like a list one, like your first line should say like L1, right? Beneath it'll say like frequent list. Don't put it, make sure there's nothing in there. So if there's something in there, hit delete, make sure there's nothing in that. Go to the very bottom, hit calculate. And you're always going to be using one variable stats because this is a one variable statistics class. I don't teach you two different variable statistics, okay? Or multi-variable statistics. Just one bar stats. You see the little button that says that, you see when they do that, what does it say on next bar? That. It just did all the averaging for you. Okay, so you don't have to sit there and do this. Because guess what? I think in some of your Hawks questions, they're going to give you like 35 numbers. And they're going to say, hey, take the average of this. And you're like, bro. Or pop them in your list function. There's a lot of other things that little list says on there, doesn't it? You're going to be using them all. Okay, that's the difference between either A, having to try to, I'm going to show you some formulas. Doing those formulas one at a time, over and over, iteratively, or plop it in your calculator, be done just like that, okay? Good? Was everybody able to get that? Okay? If you weren't, if you're near somebody who just did it and they're not getting it, show them, go, look, this is what I did, okay? And like I said, once I get the camera working, I can kind of show you. I even tried before class, I tried to get it working. But your stat button is going to be right about here. They're stock, okay? Right there. Once you hit stat, you're going to see the word edit. It's going to be the first thing highlighted. You're going to click that. Then you're going to see a whole bunch of list functions, okay? Or lists, okay? Good so far? So far, so good? Okay. One last thing, and then we'll kind of call it a day early, because I don't want to get too far into this. I want you to have a chance to kind of work with this, work with your calculator. First off, if you don't have a calculator, you're sitting there going, crap, I don't have one. Don't worry, you got time, get it, work with it over the weekend if you can, really get in there. I've got notes down, so you can go back in and practice. Everything's written down. Notice here, weighted mean. I had to rewrite that there. It's wrong. It was 59. For some reason, I was like, why not put 69? So I already wrote it out. It's changed. It's not changed in the video. We'll see who finds it on the video. Weighted mean, well, this is my weights and measures for last semester. Okay, of course, it's different this semester, but this is how Canvas calculates your grades. When I say you have homework, I put it into a little box and that box is weighted. Okay, and then so on and so forth. Well, you can do weighted means. Okay. You can also find weighted in your homework. It's gonna say, hey, find out what grade you have to have. Okay, good news is your Canvas does this for you. But you can figure it out. But notice on this one, I say, hey, homework discussions, this person made 100. That's the average. Every single one of those is an average, okay, of what they made. And then I pop it in there and then I assign the weight. So on and so forth. You can see how I worked that. I did 100 times that weight, 81 times that weight, added to the 43 times the weight and so on. And then I divided by, well, 100%. Which actually doesn't change anything, it's just gonna be 100%, but you can change it to whatever you want on the bottom. Or, if I don't wanna do it that way, I can record that 100, the 81, the 43, and the 52 in my list 1. Go back to my list, on the list 2, I can put what? I can put the operative weight next to it. And then when I go back and hit calculate, notice on when you go back to calculate, it says that first button says what? L1. The next one says frequent list. I'm gonna put L2. Then whenever I hit calculate, it's gonna go, oh, so you want me to start calculating all this for you and then give you a sum. And there you go. So notice instead of you having to do that, once again, your calculator does it for you, okay? You won't do any more weighted means after this lesson. Okay, so it's sort of like one of those, you learn how to do it, but now you kind of know how your Canvas show works. I mean, this is literally how we take grades at this college. That's exactly what's running in the background. And except I'm not having to sit there in my office going, okay, she's got this and I'm gonna have to do the math. I'll be okay, but do you really want your English professors having to do math to try to figure out your grades? I know all the English professors, they all hate math. Trust me, you do not want them calculating your grades by hand, okay? So no, that's how weighted grades work. Hawks will probably do this with you, I believe. They may say, what is the grade of, if this person wants to make like a 70, so they may say, hey, here is gonna be an X. Right here. But then they may say if they have to make a 70 or something like that. And you just solve for X. You've all done that. You've all passed college algebra. You can all solve for X by now. Okay, so you're just gonna have to do that. After that, we'll get into meeting. Brenda, how do you feel about your calculator support? Did everybody end up getting it who has their calculator? Is everybody good with how to get to the list? You really need to know how to get to that list, okay? And how to put stuff into it, okay? Let that become something that becomes second nature. We'll get into some of the, I'm not gonna say tips and tricks. They're not tips and tricks. You're gonna use these to make your life easier, okay? Because yes, you could put all that into, do it all by hand. I've had students do it, okay? I have had students pass 1, 3 and their midterm, okay, without the graphing calculator. And I had 2 students do that last semester. They all came up to me and said, oh, I wish I'd have got that graphing calculator. Because literally the equations get about as long as a sheet of paper. Okay, because you have to calculate the same thing like 30 times. Over and over and over. That's stupid. Whenever you could have just said, I'll put my calculator. Hit a button, it's done in like 2 minutes, okay? The hardest part, and I'll let you go after this one, I need you to pay attention. The hardest part where people mess up, like anything else, you get lazy. I do too. You get too fast, okay? When you put those numbers in, always double check them. Because as I tell people, that calculator is always gonna give you the right answer of what you put in it. Okay, and these aren't pretty numbers like you got in intermediate and college algebra. These numbers are gonna be ugly, really ugly. There's not gonna be any intuition that says, I think this is right. You know, like you did the word problems in college algebra, if you're like studying a plane, how fast it went, if you got 1,000,000, you're like, I probably did some bad math. There's no plane that's going 1,000,000 miles an hour. This math is gonna be like, dude, that's an ugly decimal. I guess, I don't know. Maybe it works, maybe it doesn't. So you're gonna need to kind of just make sure you do the right math, the right things in your calculator, okay? All right, I will see y'all next week. If you have any troubles with your calculator, let me know. I'll try to send videos. I do think there's videos online too as well.